Thank you, everyone. This is the Society and Conservation Biology Emerging Issues in Conservation seminar. My name is Javier Basurto. I'm an associate professor at Duke University, and I'm hosting this seminar today. This is a seminar organized from papers that are coming out from the 3 journals of the Society. And it's my pleasure to introduce Professor Katrina Davis today. She's an associate professor in conservation biology at the Department of Zoology at the University of Oxford and a tutorial fellow at Balliol College. Her research identifies optimal use of natural resources to maximize the productivity of ecological and social systems. Her work combines bioeconomic and demographic modeling, non-market valuation, and optimization approaches. Katrina completed her PhD in 2016 through the School of Agricultural and Resource Economics at the University of Western Australia. She holds an adjunct research fellow position at the University of West Australia, a School of Agriculture and the Oceans Institute at the University of Western Australia, and at the Centre of Excellence for Environmental Decisions at the University of Queensland. Without further ado, it's a pleasure again, Katrina, to revisit your paper that I enjoyed being an editor for. Thank you for being here today.
Thanks very much, Javier. It's a real pleasure to present at this seminar series. I've been watching it with interest, and there's been some great papers highlighted. So I'm very excited to have the opportunity to highlight this research as well. So this is a paper that came out, was published in Conservation Letters this year. Well, appeared online last year. There you go. So this paper is Local Disconnects in Global Discourses, the Unintended Consequences of Marine Mammal Protection on Small-Scale Fisheries. So this is work, obviously, with a range of collaborators, co-authors, who are listed here from a range of time zones in different countries. So I'll extend a good morning, good evening, or good afternoon to all of those who are watching this now and who will watch it in the future. So some of you may be familiar with the expression human-wildlife conflict. For many people, it evokes similar scenes to what you're seeing here, this idea of lions killing livestock or elephants raiding crops. At its base, what we're really dealing with is a problem between humans and wildlife. And there are further extensions of assessing problems between humans and humans, but today we're going to focus on problems between humans and wildlife. Now, this is problematic, largely because, as we conservationists know, people are very complex beasts and they have very different motivations and preferences. It's also difficult because at its heart, apologies, I'm a new Mac user and I keep losing my screen. This doesn't happen on a PC. Phew, got it back. Okay, so it's also difficult because really we'd like to be able to predict the response of wildlife to human actions, and those actions can be retaliatory or conciliatory. Managing human-wildlife conflict also pushes us up against some conflicting policy ideals. So on the one hand, there has been a really strong global appetite for wildlife protection, and this is expressed through a range of international and national wildlife protection policies introduced in the 20th centuries. On the other hand, there's been a big focus on achieving improvements for human well-being, largely exemplified in the Sustainable Development Goals. The Sustainable Development Goals have particularly focused on improving livelihoods in less developed countries. So immediately when we're managing human-wildlife conflict, it's apparent that there are going to be some trade-offs that are involved. And what has made this really difficult in a marine setting is that we don't have a good idea of the costs or the consequences of these trade-offs. We know that marine mammal protection, for example, can impose costs on fisheries, and we know that fisheries can threaten the recovery of marine mammal populations, but we're still really lacking quantitative evidence in this area. So what we've seen in the marine environment has really been the consequences of centuries of whaling and other harvesting activities. What these actions have done is really decimated many of our marine mammal populations all the way around the world. So marine mammal populations are estimated to have declined by about 71% relative to historical abundances. And tracking this change relative to this mythical, historical abundance pre-whaling and harvesting is really difficult. But what we've seen in the 20th century really is this introduction of a range of protective legislations. And this legislations in different sort of national jurisdictions or international jurisdictions has really helped reverse declines in these marine mammal populations. So much so that, in fact, what we start to see is that specific marine mammal species are coming into direct competition with fisheries. And this competition, on the one hand, has really serious implications for fishers, particularly small-scale fishers who are often income insecure. They're in these less developed countries. And what this does is lead to a real tension from a management perspective. Countries are often committed to marine mammal protection policies, so they have very little flexibility in that area, but these policies can be very damaging for fisheries. So for all of you visual learners, I'm including a video I like to show, hopefully to give you an idea of the difficulties that fishers come up against when they're interacting with marine mammals. So this footage is recorded off a fishing boat in Alaska, and these are stellar sea lions. So hopefully this can give you a bit of an idea when we're thinking of these charismatic animals, marine mammals, it's difficult to see how they could be damaging or cause real significant problems for fisheries. So hopefully this footage can give you a bit of an insight there. Why do we have this conflict between recovering marine mammal populations and fisheries? Really, it's a question of spatial overlap. So this is a map of the spatial distribution of different pinnipeds. So this is a class of marine mammals, sea lions, seals, and walruses. And so this is using IUCN data to understand where these animals are distributed around the globe. This, on the other hand, is these two images are showing a distribution of fishing effort around the globe. So this is from Kreutzmer et al. In Science and Hicks et al. In Nature in 2019. So in the top panel, the darker green or slight tinging to purple areas are areas with higher levels of fisheries effort. And in the bottom panel, areas with darker purple are where catch is highest. So hopefully you can see from these two images that really our fishing effort is concentrated in coastal zones. And that's problematic for a number of reasons. When we think about a lot of pinniped species, that's largely because these animals haul out. They come onto shore to breed, to recover, for other grooming activities. And that means generally they're really in the firing line, or they're in the perfect place to cause trouble for fishing industries. So what we see around the world, this is early results from a meta-analysis that my group is doing, led by John Jackson, about the impacts or the economic impacts of interactions between pinnipeds, such as sea lions and seals, and fisheries. And we see a really different story around the world. So these impacts can range from, losing up to 80% of commercial revenue because of interactions with Californian sea lions, up to sort of really negligible impacts, light interactions with gear, which is the case often for the Australian fur seal. So the research question that we addressed in this paper was really to understand what's motivating conflict from a fisher's perspective. Sort of a priori, certainly with a background in economics, my first thought is to think that it's really economic impacts or damages that are motivating conflict with sea lions and seals. But through discussions with some fishers in different areas of the world, we began to suspect that actually wasn't the case. And so this was a research area we wanted to get to the bottom of. So this part of the world that we're focusing on is Peru and Chile, so the west coast of South America. These are both mighty fishing nations. So Peru is in 2018, which is the latest data we have FAO data for, was number 3 in the world for fisheries landings, marine capture fisheries, shared with Indonesia, who's number 2, and Chile was number 10. So these are big fishing countries, lots of in these particular areas, lots of small-scale fishing fleets which are operating in coastal zones. And if you look at our distribution of our pinniped species, we've got 2 main pinnipeds in this area, the South American sea lion and the South American fur seal. So the question we're asking here, or that really needs to be addressed, is for policymakers who are operating in this space and trying to look after the welfare of their small-scale fishers, but also trying to meet commitments they've made to marine mammal protection, how can they solve this conflict? And part of being able to solve this problem is really understanding the motivations for the conflict. Okay, so this is a bit more background detail for you about where tempers are lying, or how high tensions are in Chile and Peru. This is from a newspaper in Chile in 2018, a few years ago now, and it's describing this dramatic fight between fishers and sea lions for food. So what tends to happen with fishers and sea lions, On the one hand, it's difficult for fishers because sea lions will interact with gear. So they'll typically steal fish from nets, and in the process, they usually damage those nets. And on the other hand, we get concerned because what can happen is that fishers can do their best to protect their catch or to sort of scare sea lions away from their nets. And what can happen is that they can get killed or be killed by fishers who are just defending their catch. So indication of public sentiment in this towards this issue. So the animal species that we focused on in this research is this very charismatic individual, the South American sea lion, Ataria flavescens. So this animal is known to have very highly developed cognitive abilities. And that's really important because what's happened is we've seen a change in behavior in this animal, and this is no means unique for this species. What we've seen is that instead of being, a foraging animal, which is, foraging for its food and surface and coastal waters, this behavior has changed to a sit back and wait approach. And really sitting back and waiting for a fishing boat to come and then to steal the fish from the fishing nets. So in this research, we worked with NGOs and a range of collaborators around the globe to identify the key drivers of conflict that fishers that might be driving this conflict from a fisher's perspective. We again with the ultimate objective of developing better management solutions. So human-wildlife conflict, we've mentioned this idea of a spatial overlap being a real sort of driver or cause of conflict. What we tend to see, or why that's been exacerbated through time, is, as I mentioned earlier, we've seen this real recovery in many marine mammal species, and that's particularly true for sea lions and seals. So these animals, because of their life history traits, can have these really quick population recoveries, relatively quick population recoveries. So here you're seeing Peru and Chile. This is the number of South American sea lion in both of these countries. And what we've seen is this real recovery since about the 1970s. So Peru's on the left-hand side, Chile's on the right. And this is population size in the hundreds of thousands of this animal on the vertical axis, and then time on the horizontal axis. So you can see that this is from the 70s. So if you think about the average working life of a fisher, 30, 40, sometimes 50 years, what has happened is that we've seen this really strong increase in the populations of these animals within the working life of fishers operating in this region. So I've given myself a bit of a strategic pause for breath here. I'm having slight health issues this week, and just in case I need it, you'll see little pictures of charismatic grey seals dotted through this presentation. Okay, moving on. So our approach in this research then was to use survey-based methods to understand what these drivers of conflict are for fishers. So we surveyed 300 odd fishers across Chile and Peru. We used a best-worst scaling survey, which I'll go into in more detail, to understand the key drivers of conflict with sea lions. And of course, we collected some additional socioeconomic and attitudinal data. So this was the first question we asked fishers. What was the first word that comes to you when you hear the word sea lion? This is a word cloud. So the size of the word indicates the relative frequency with which it was mentioned by fishers. And you can see that across all of our respondents, so 300 respondents, for most of them, it's this concept of damage. So they're not, charismatic animals happily occupying the same marine space, and so they're these real predators that are very harmful and destructive for fishers. So what our team did was to identify a range of drivers that we thought were probably of most concern to fishers regarding their interactions with sea lions. So these drivers spanned a whole range of concerns, including population growth of the sea lions, behavioral changes in sea lions, economic impacts, health and safety concerns. What we then do is use a best-worst scaling survey, which I mentioned, which is a form of discrete choice experiment. And what it does is really takes advantage of the fact that it's much easier for people to identify what's most important and what's least important from a list. So we have a number of survey versions for this. Each respondent scored 12 questions. And this is the sort of question, this is what these questions look like. So I show you 12 different versions, all slightly different with different options. And then I ask you to choose your most and your least important concern regarding sea lions in each of these. And then we can analyze these questions to understand the breakdown of concerns across our population. So this is the average result that we saw for our population. What we're seeing here is drivers of conflict on the horizontal axis. These are our 12 drivers, potential drivers, and then our vertical axis shows the relative importance of each driver. And what we see across these is that really economic problems are a concern for fishers, but actually what's most concerning for the average fisher in our sample is that there are just too many sea lions, that these sea lion populations really are too large, and there's this perception that they're really expanding very quickly. For context, remember that these animals are still probably classified as recovering. We're not seeing a population explosion here. What we're seeing is a recovery, but within, we mentioned before, the working life of the fishers operating in this region, it's hard to observe, to view this population increase as recovery, and it's more like an explosion. So what's useful for us when we're analysing the responses for these data is from these surveys, is not to think of our respondent population as this sort of homogeneous mass. We know that there are fishers with different preferences, different understanding of how their interactions with sea lions cause them problems. So what we can do is move away from the previous approach, which was a conditional heteroscedastic conditional logit model. Actually, I think, apologies, it was just a conditional logit model, and we use a scale adjusted latent class model. And what we're doing this for is to understand heterogeneity in fishers' preferences. So effectively what that means is we're identifying groups of fishers who think the same. So membership is determined probabilistically. We're using a multinomial logit model. Apologies, struggling with my words today, and I'll take you through those shortly. So once again, we see the same 12 drivers on the horizontal axis, and again, important scores on the vertical axis. So the more important groups of fishers a given driver is, the higher the importance score. So what we see is that for 3 of these groups of fishers, concerns about population size and increase are shared. It's their most important concern. What they view is really the cause of their concern about sea lions. These groups of fishers then have slightly different composition in terms of their other concerns. And then our 4th group is more concerned about inputs and safety and time. They're not so concerned about population size. So what we can do then is go to our multinomial logit model. We can understand the qualities or the characteristics of our respondents that make them more or less likely to be in one of these preference groups. So the 3 variables that explained membership of these different groups were whether respondents were involved in sea lion tourism, what they thought was the impact of sea lions on earnings, and their nationality, whether they were from Peru or from Chile. So we named our groups, of course, to make them a bit easier to identify. And our first group is the economically minded group. So these individuals are far more likely to think that sea lions have a negative impact on earnings. They're also less likely to be from Peru. In yellow on the top right-hand side, these are what we've described as our alternative livelihoods group, purely because they are themselves involved in tourism or they know someone else who's involved in tourism. Our blue group is our lifestyle impacts group, more likely to think that, to be concerned about the impacts of sea lions on, for example, the time. They're having to spend more time fishing, to fish to different areas, more time mending nets, and about the safety concerns of sea lion interactions, which is largely, again, this idea that they're having to go further off the coast to fish. And then our final group in green is really concerned about capacity. Once again, the impact of sea lions on input costs, so having to replace nets, but again, these safety and time concerns. So I'm going to take another strategic breathing break here. So what does this information tell us? We found that there is reasonable heterogeneity in what different groups of fishers think is really driving their problems with sea lions. And where this becomes useful is when we're identifying solutions for human-wildlife conflict in this case. So how can we tailor our solutions to manage this conflict between fishers and sea lions, knowing the different characteristics and the different perceptions of our fisheries groups? So what we did, we went to the terrestrial human wildlife literature and reviewed studies reviewed this literature to identify solutions that we thought could be applied in this particular context. So we've classified these into sort of two broad categories, the very top vertical lines here. On the one hand, looking at removing the problem, and this is basically a management solution, which is culls, so culling these animals or killing some percentage of these animals every year. And then our second option is solutions really which are about living with the problem. So different ways that we can change the relative costs and benefits of interacting with these animals. So these focused on economic incentives, capacity building programs, and alternative livelihood programs. So because we know the characteristics of our different fisheries groups, we can target these management solutions to the different groups. So for example, our economically minded group and our capacity focused group in our second column, our red and our green groups, are far more likely to be influenced by economic incentives rather than alternative livelihoods approaches. So some examples of what each of these different management solutions could look like. What I'll do is I won't go through all of these, but we can think about different benefits and costs of each of these management solutions. So certainly in the terrestrial literature, we've seen that culls of wolves or bears or other terrestrial, usually large-bodied predators, these culls can really help to manage public sentiment. They can help gain stakeholder support, and often they're shown to reduce illegal poaching of these animals. So there's a legal method through which steam can be vented, which reduces sort of this ill will towards these animals. On the other hand, there's very little evidence to suggest that where you've got two actors competing for the same resource, in this case, you've got fishers and sea lions competing for the same fish stocks, there's very little evidence to suggest that culls will actually have an increase on fisheries, will actually improve fisheries yields. That's probably not what's happening. And instead, they could actually have really quite significant negative impacts on these marine mammal populations. And then there's a range of other solutions that we identified, each with their own benefits and costs. But again, focused on this idea that we could be targeting these solutions to our different groups of fishers. So our next question then focuses on the perception of well, fishers' perception of the impacts that they're experiencing because of sea lions, because of pinnipeds. So I'll caveat this data by saying that this is, perception data. This is data that's come from an interview with fishers where a priori you would expect them to have an incentive to inflate the impacts of sea lions and seals on their fishing activities. On the other hand, when we're managing human-wildlife conflict, we're actually often focused, or we're more concerned about these perceptions than we might be in other situations, largely because we're managing public sentiment when we're managing conflict. So, caveat over, what most fishers perceive is that they're losing at least 26% of their catch because of interactions with sea lions. So this is on the vertical axis is percentage of respondents, and horizontal axis is impact of percentages on catch. So the dashed vertical line shows sort of the negative and positive side. So estimates at the left of the negative dash are negative impacts on catch, so catch losses because of sea lions, and on the right hand side are catch gains because of sea lions. So there's not a lot of it's quite a clear story here. Most fishers think that they're losing really significant amounts of catch because of their interactions with sea lions. It's the same story when we look at income. Again, percentage of respondents on the vertical and impact percentage on income on the vertical, horizontal. Estimates on the left side of the far left dashed line are negative impacts, and estimates on the right side of the far right line are positive impacts. So from fishers' perspective, really, they have a very solid case to argue for policy help, for some intervention from marine managers, from policymakers, to alleviate these impacts that they're experiencing because of sea lions. So these are protected species. Fishers view that the Marine Mammal Protection Acts are really causing them significant and personal losses to their livelihoods. This becomes more important when you remember our research context. We're operating on the west coast of South America. Most of these fishers are not making minimum wage. They're earning less than minimum wage, and most of them are the principal income earner in their household. So, they have a family which is dependent on their fisheries income, and that income can be really strongly impacted, or that's their perception, by these sea lion interactions. So from a conservation perspective, these perceptions are also really important because we know that sea lions in this area are killed by fishers in order to defend their catch. So this is very difficult information to get at because this is an illegal behavior. These animals, which I should have mentioned previously, my apologies, these animals are protected. So it's illegal to harm sea lions in Peru and Chile, and that is largely to do with the US Marine Mammal Protection Act. So these countries both export fisheries products, different fish stocks to the US, which means that they are bound by the US Marine Mammal Protection Act and have to be able to demonstrate that they have not intentionally harmed marine mammals. So what do fishers think in our study area? Well, fishers think that the majority of vessels are killing sea lions in order to defend their catch. If we unpack the estimates that we get from fishers, again, we're not asking fishers, are you illegally killing sea lions? Instead, we're asking them about what they think the behavior is in other boats operating in their area. So the majority of fishers think that 67% of boats are killing sea lions. And then when we ask how many sea lions are being killed per month, we get, again, a positive number. So this figure here shows the north, central, and southern regions of Peru, which is groups respondents into these regions to protect the identities of individual ports. So the left-hand side shows the estimated number of sea lions being killed by an average boat per month in Peru. And the right-hand side shows our fishing localities where the size of, where we did our surveys, the size of the dot circle indicates the number of fishing boats which are registered for that area. So for example, Puerto Pesaro has a large number of boats registered to that area. So what I would like you to take away from this is A, that the estimated number of sea lions being killed by an average boat each month is more than 0. These estimates could not possibly be true. They're way too inflated. There aren't enough sea lions in Peru for these estimates to be valid. So they're suggesting that far more sea lions are being killed per month than actually are currently found in Peru. But again, it's indicating this sentiment that fishers are responding to what they perceive as these really negative impacts of sea lions on catch and income by killing these animals. And it's the same story in Chile. So again, this is the same data for Chile. And once again, grouping data into north, central, and southern regions. Okay, so what we see here then is this really a two-sided story. On the one hand, we have this recovering marine mammal species, sea lions, and also seals operating in this region. You know, it's only really been the 20th century where these populations are coming back sort of from the brink. We have concerns about their population trajectories through time. They have a life history which allows their population to recover quickly from threats, from disturbances, but also to decline very quickly. On the other hand, we're working with fishers who are very marginal economically. They've got low income security, they're the principal income earners in their households, and they're experiencing these really negative impacts because of these animals. What we've done in this research is really seek to understand the perceptions of different groups of fishers with the idea of being able to sort of better target solutions, develop better solutions to manage this conflict. So we've got, our different groups of fishers who we think will respond better or worse to different management solutions. It is worth saying, though, that over 70% of our sample, when asked what would be the best solution to this problem, said that culls, killing sea lions would be, removing some of the sea lion population would be the best way to manage this conflict. So we know culls, I mentioned earlier, have worked for some species, again, but really this effectiveness is probably linked to managing public sentiment, and I'm sure we can think of better ways of doing that than potentially having these really large negative impacts on these recovering marine mammal species. We also really can't sanction culls without having a really strong idea of what would be the impact on the population dynamics of these animals, particularly in Chile and Peru. This is an area of the world where very strong El Nino impacts are experienced, which have severely negative impacts on not just marine mammal populations, but seabirds and other marine mammal species operating in these coastal areas. Okay, so coming back to our research questions, what is motivating conflict? For the majority of fishers, it's this perception that these populations are exploding. They're far too large. When we look back at the trajectory of recovery of population size of these animals, that's totally understandable. For the majority of fishers, I think the average number of years operating as a fisher in our study area was between 30 and 40 years. So for the majority of them in their working life, these populations, they have exploded. You know, conservationists, we can come in and say that it's a population recovery, but for the fishers operating in this region, it's a population explosion. So what solutions will be suitable for different fisher groups? Really tailoring solutions based on the perceptions and the needs of our different fisheries groups is likely to have the biggest impact. And how do pinnipeds affect fishers' welfare? In many cases, very negatively, or at least that's the perception. So Javier, I have some additional material, but I'll defer to your judgment on whether to go through that or whether to wrap it up now.
We have 23 minutes total, so I think we can keep going, and if we leave 10 or 15 minutes for questions, will be good. So that means you can go for 10 more minutes if you want.
Perfect. I'll reset my clock. That will give me an idea. Okay, so I mentioned that it's really difficult for us to sanction population culls, which is really what fishers in this part of the world, and realistically in most parts of the world, culls are usually the management option, which is most popular. We need to understand what would be the impact on the population dynamics of these animals, I mean, in order for us to sanction this management strategy. So I'm moving on now from results which are based on our paper from Conservation Letters, and this is additional work that we've done as a follow-up. So in this current analysis, our objective was to understand how our South American sea lion, this time just focusing on the Chilean population, is likely to change over the next 30 years. So on the right-hand side, this is, apologies, this is not complete. This is the northern locations of sea lions in Chile. I'm missing the southern extent. So the objective here is to understand the likelihood that this population in particular will go quasi-extinct. What's the likelihood that the population will not be large enough to sustain shocks, will not have enough genetic variation in order to be able to sort of weather out environmental variability. And specifically here, we're not just interested in the population dynamics, but we'd like to understand what would be the specific impact of different cull regimes if we were to go down that management route. And we need to know what the impact of culls would be, given that there are these extreme climate events which occur in this part of the world. So to do this, I haven't given you the full detail here, but this is using demographic methods to understand population projections, specifically matrix population models. So up on the top of this slide, I've got a life cycle model for the South American sea lion. In this analysis, we've just used a female model, largely because this will surprise you all. We don't have very detailed demographic data that could justify a more complex life cycle assessment. So what we are able to do, and I'll go through these methods shortly, is to assess what's the likelihood that of our adult females are surviving, that they're reproducing each year, the likelihood of pups surviving, and the likelihood of pups surviving and becoming adults. So using this information, we can then project our population through time. I mentioned that we don't have a lot of data in this area. In fact, we have almost no data in this area. We don't have detailed demographic rates for this animal. What we do instead is we borrow phylogenetic power. So using a phylogeny from VertLife of different marine mammal species, we can beg, borrow, and steal demographic data from other pinniped species, which is found in the animal matrix database Comadre. So we have information on the demographic rates, the vital rates, how these animals grow, reproduce, and survive through time. And we can infer what are the likely estimates, what are the likely vital rates for our target species. I'm not going into extreme data here, but suffice it to say that what's of real interest is to understand really to be able to incorporate our uncertainty into this analysis. So we're inferring vital rates, how our South American sea lion grows, reproduces, and survives through time based on similar data observed in other species. So there's a lot of uncertainty we have to incorporate. If we take, based on our analysis, we can project what we think is likely to happen to this population through time. This is based on a starting population size of 100,000 females. This was from the latest Chilean census, which was in 2019, I believe. So our first data point on the left-hand side is 100,000 females. So the vertical axis here is showing population size in and then we've got the years of this analysis on the horizontal axis. So each of these lines is a model iteration, again, which is just being informed by the uncertainty we have in these vital rates. So at every time step, we're drawing from a sample of vital rates, which were informed from our analysis, which drew on phylogenetic power from related species. Based on that, so based on the best estimates we can currently do for this animal in terms of how it grows, reproduces, and survives through time, we would actually project that, contrary to common expectations, this animal species is not sort of exploding. It's actually at a point where it could very quickly tip the other way. So I mentioned that the life history characteristics of sea lions mean that they can recover very quickly, but they can also be disturbed very quickly from various factors which perturb their population. So the dark line here is the total population, that one of the dashed is adults, and the smaller line is juveniles. So juveniles is a combined category of pups and juveniles. So on the vertical axis, the dashed line is the year at which we expect this population will go quasi-extinct. So there's not enough genetic variability or variation in the population to allow it to persist through time. So this is quite a surprising result, a priori, based on the population projection or the population trend of this species. They look like they're recovering and are recovering strongly. What these results really show us is that, based on what we know about how this animal and other pinnipeds, on the vital rates of these animals, they are really vulnerable to quick changes. So when we're thinking about management solutions, we can't assume, a strongly recovering population, because actually the reverse might be the case. So if we were then to introduce managed culls onto this population, so say we could remove 15% of animals in year one, or we could do a 10% cull every year, or we could cull 30% of the population every 5 years. There's various different scenarios that we could take, and this is useful for us because each of these will have different costs associated with them. It's often easier to target adult females, for example, but we could have different impacts on the population depending on how we sort of remove animals each year. So it won't surprise you to know that culls will sort of speed the decline of this species past our quasi-decline threshold. So the top panel here is showing what would happen if we culled 15% of adult females in year one, 10% of adult females every year, and then 30% of adult females every 5 years. Again, population size on the vertical, and then our time horizon on the horizontal. It's sort of tricky to think what could be worse than these scenarios we're already looking at, but we did mention that climate change or extreme climate events are really problematic in this area. So extreme climate events typically last 12 to 18 months, and we can use a Markovian transition matrix to model the progression between good and bad years. So in bad years, bad El Nino years, what we've observed previously, this was from the 1997-98 El Nino event, is that we lost 100% of juveniles and 60% of adults. And had a really strong decrease in fecundity. So we can use this impact on our vital rates to project our population through time, incorporating these impacts of extreme climate events. I won't take this breathing break, but it won't surprise you to know that even absent culls, what we see is this really sort of quick decline of this population past our quasi-extinction threshold point. If we combine culls and climate, then that sort of speed of decline just moves forward in time. So in the case of a 15% cull of adult females in year one, that's quite a large increase. And 10% of adult females, not so much. Okay, so really we're reinforcing our management solutions here. Our population looks like it's strongly declining, but is vulnerable to sort of extreme reversals in this. If we were to introduce culls and extreme climate events on these population dynamics, we're just going to increase the speed of decline. What this means is that our conflicts with fisheries really should be managed with other tools. This population is likely to be very vulnerable to these stochastic extreme events. And so management culls don't look like a good option. So we can rely on these other solutions, economic incentives, capacity building. But again, our results are highly dependent on certainty around vital rates. So are we likely to have had this population, which is recovering strongly, just to have this complete reversal in a short period of time? What we really need is better data on how this animal grows, reproduces and survives through time. So when we're reducing uncertainty in vital rates, what we really want to be doing is tracking individual animals and observing these processes from year to year. What we're now doing is, of course, using unmanned aerial vehicles to do this. And I'll skip forward to some data that we've just collected from the Farne Islands. These are the grey seals you've been seeing, where we've been using drones to survey these populations. And some exciting developments that we have is that we're now using thermal drones. So we've got thermal imagery of these animals. And what this really allows us to do is just improve our estimates. So using drones to do aerial censuses of these animals can be difficult. Again, we have the rock or the seal problem, and using this thermal imagery, we can really overcome these. Okay, so I'm gonna wrap up there. This is footage again from the Farne Islands. And just really the power of our ability to better observe these animals with digital, with drones. So I will finish with a thanks to all the collaborators involved in this work, my co-authors from the original paper, and thank you all very much.
Excellent. Thank you, Katrina. We have 13 minutes before the hour, and there's a couple of questions that have already come in. My preference is that everybody opens their microphone and everybody each asks their own question. I think we'll make it livelier. If not, I'm happy to ask the question. But Martin, do you want to go ahead with yours?
Yeah, can do. Thanks, Katrina, for a really interesting talk. I was wondering, as you were delving into the culling scenarios, I was wondering what the general perception outside of fishers, outside of the fisher community is in Chile and Peru with regards to culling. Do you have any insights into that?
I do not know, and I would be interested to know. So we've done work examining Chilean perceptions of marine energy installations, for example, and we've really been able to identify a young, educated, wealthy class who are really concerned about the impact of marine energy installations on marine mammals, and then an older, more likely to be less educated and less wealthy class who are really concerned about economic impacts. So it really wouldn't surprise me if a large, percentage of the Chilean population was really concerned, equally concerned about the conservation outcomes of these animals. It would be a really interesting study to do.
Thank you. Alison, are you there? Do you want to ask your question?
Sure, I'm here, Javier. Thanks, Katrina. I enjoyed that. I might have missed it. I came in a little bit late, and then busyness as usual. But you did mention the sea lion population is recovering. Obviously, they're now protected. But I'm sort of trying to compare this to Martin. You'll probably know more about this than Namibian seals and all the issues there. It's kind of a similar scenario. What has actually worked to ensure their recovery? Actually. You did mention a few things, but if you could name sort of the key thing, why have they recovered so well? So
not harvesting them, basically. So, these animals were harvested right up until the 30s. The legal protection for these animals has been very inconsistent through time. But essentially, I think, I have to rack my brains for this, but in the 19th century, I think even incentives were still being offered to sort of harvest these animals or to cull these animals. The South American sea lion has generally just been regarded as a nuisance species. So there were, like in many parts of the world, economic incentives offered, per sea lion killed. On the other hand, fur seals, the South American fur seal, much more likely to be exploited for its meat, fur, pelt, internal organs. So sort of we had exploitation on the one side and then culling on the other of these animals. So really, it's been the introduction of protective legislation, which has really been the key.
Okay, so that's been named as sort of the individuals, but as far as habitat protection goes, have any islands been declared sort of protected areas or anything more than that?
No, which is interesting. So Chile doesn't have a great record of protected areas. So Chile has a really large protected area around Easter Island, which is, aimed at whale migration patterns. But coastal protected areas have been a bit slower off the mark. So this is now an issue that we're exploring. So there is now a protected area. I'm not sure where it is. And actually, we were interested to see whether fishers thought that was the problem, that these animals are increasing because they've got this protected area. Still to be investigated. We don't see huge numbers of these animals getting caught as bycatch, which, stellar sea lions, etc., etc. New Zealand Furcio, I know bycatch is more of a problem, but it hasn't been in this area. So it's an interesting question. All else being equal, I assume that the law-abiding nature in general of fishers to not harvest and not cull when the legislation has changed has been the key causal mechanism. Most of these large animals are pupping in areas outside of the central region of Chile, around Santiago, and there's been concern that some of the whole out areas have changed from breeding to non-breeding grounds in the central region, again getting at this sort of habitat competition. But Chile has large sections of largely inaccessible coastline, which may be acting in this animal's favor. So that's speculation on my part, Alison. I'm not really sure.
Okay, no, great. Thank you for that.
I actually have a follow-up, thinking, it might be a very interesting comparison to see or to look at areas that have protected areas, fishers, and sea lions. And I cannot help to think in the places I work in the Gulf of California with Salupus californianus, the sea lion there. It was harvested in the past. It's protected now. The Gulf of California islands are protected areas, and as far as I can see, the interactions are increasing with fishers. You hear of fishers shooting them, but it's nobody wants to admit they're doing it. But it's clearly the population has gone up. So I just think it will be interesting comparisons there. I also had a question about cooling, and you mentioned in your presentation that cooling will not increase fisheries yields. Can you elaborate or expand why, even with cooling, fisheries yields will not increase for fishers?
So there's been some simulations that have used these sort of multi-species assemblage models to try and unpack these dynamics. But essentially, we have so little ability to say, you remove this predator in order to increase the abundance of this prey species. And instead, a predator operating on a different trophic level is not just going to pick up the slack. So, I move this predator, that just releases another predator to consume more of the prey species. Especially with fish, it's the size of the life cycle relative. So it might be that, juveniles suddenly become far more vulnerable to, let me see if I can get these trophic interactions in my head. Sometimes if we remove sea lions, we allow one of their additional prey species to increase in size. And that additional prey species might actually be predating upon the juvenile stage of our target stock species. So the species that fishers are, to target stock, that's what they want to be catching more of. But I hesitate to use the term mesopredator release, but effectively that's what's happening, right? So a secondary prey species of the sea lions has increased in abundance. They've increased their eating consumption of juvenile individuals of our target species, and therefore, removing the sea lion has done nothing. So this is a really exciting area of research. It's sort of not my specialty, but I really want someone to come on with me to do sort of understand under what sort of trophic interaction conditions removing your apex predator is going to have an impact on your prey species. At this stage, we think there's no evidence anywhere in the world, and certainly in South Africa, they looked at this to suggest that removing your apex predator is going to do anything. So that's from the top down. On the other hand, there are parts of the world where orchids are, predate upon seals. Anecdotally, I can say that typically what we see is that top the apex predator operating in a marine environment tends to be the species having troubles with fisheries. So orcas, interact with fisheries. They do the same thing. They steal fish, they break nets. But in those areas, we don't see a lot of sea lions or seals interacting with fisheries. Yeah. I don't know how it's a tricky one. There's very few conditions under which we would expect to remove the apex predator and then have an increase in our target species abundance. But that's really difficult to communicate to fishers who are operating in the area, as you can expect.
Yeah, and going back to Martin's question, yeah. We have time for one more question if anybody wants to jump in. Martin.
Thank you. Yes, Katrina, I was really interested in you delving into the heterogeneity of people's perceptions of the drivers of the human-wildlife conflict. Because my perception certainly, and it might be wrong, I'm not really up to speed with human-wildlife conflict literature, but my perception locally is that if there's crop damage by elephants breaking out of national parks or something, that our general approach is everybody feels the same about this. And yeah, I don't know if Alison has got further insights into this, but that's my perception. And I think it would be really useful locally if similar kind of approaches are followed with the terrestrial issues of human-wildlife conflict and try and pinpoint those drivers and how different people perceive things.
It's really tricky, especially my perception was that it was just going to be an economic problem. And so many of the Scandinavian countries, I think Norway still offers financial incentives. I always use this example. It's the Game of Thrones setting, right? So if you come to me with your scorched, livestock or your damaged catch, we will compensate you for your loss. And that comes back to this idea that it's a policy setting. Policies decided. The will of the people is that we want to protect these animals, and that has negative consequences on actors operating in these waters. Therefore, society compensates them. But yeah, it's not what we find at all. In fact, in the terrestrial human wildlife literature, even more so, remember that sea lions are really large animals. They're up to 3 meters. The males, they're tons. They're very heavy. On the other hand, terrestrial carnivores, what we often see is that it's this concern about welfare. That you've got the sort of loss of life concern introduced alongside loss of property. And that has different impacts on different people. So yeah, different people experience those relative risks or financial burdens differently.
Well, we have two minutes left. I'm really glad we could go a little bit farther after, beyond the paper to see where your work is doing. I think where work is going. I think that's a lot of interesting directions. We don't have time for a question, but, considerations of climate change calls, and I will think that getting estimations of illegal takes need to come into that modeling, because that will continue to take place. And I think as we get better with aerial, mapping and localization with drones and radar, a lot of those issues might be easier to spot. So yeah, I want to thank you, Katrina, for taking the time, and our audience, and Martin for organizing all us. So yeah.
If I could come in with one last completely unrelated topic, please, folks. I'm about to start teaching my marine section in 4th year at Stellenbosch, and I see this is being recorded. Martin, Javier, Katrina, get hold of this, because I really would love to use this with the paper as a case study for my crew.
That would be great. I think that's a great way to use the seminars, as far as I'm concerned.
So where do I go to find the recording? Martin, you quite familiar with this?
Yes, I will. I can let you know when it is up and running, just as I will let Katrina know. And I'll also it's on the SCB Vimeo channel, but I'll let you know as soon as it's available, which should be in the next couple of days.
Fantastic. Thank you all. Really enjoyed that. Thanks.
Yeah, me too. Have a good day, everyone. Take care.
Bye.
Bye.
Thank you.